everyone, welcome back to the SAT Math question of the day. Here's our question. Please read it, try it, pause the video, try it, come back, and we'll do it here. A circle in the xy plane has its center at 4, -5, and has a radius of 2. An equation of the circle is x squared minus 8x plus y squared plus 10y plus c equals 0, where c is a constant. What is the value of c? Wow. At first I guess I glanced at it when I chose, I thought we would complete the square, but no. You just plug x is 4, y is -5 into the equation, and the other side of it has to equal 4, right? X minus 4 squared. Or you can just, I see. You could do it this way, right? X minus 4 squared y equals 4. And now you just multiply all this out, and then you can figure out what c is. That's better, right?
Yeah.
That's better.
Yeah.
Yeah, that's the way to go.
Yeah.
Notice you try one idea, it doesn't, and while you're thinking it through, you realize, no, you can change paths. So that's it.
Yeah.
Then we just multiply everything out and compare terms.
Yeah.
So this is x squared minus 8x plus 16. Can't make any mistakes here. Plus,
yes, you can.
Yeah, we can, but that's going to hurt. If you make any sign mistake, it's going to hurt. I moved the 4 over to the other side, so it equals 0. Now, this is y is to double check. There's a negative sign here, so there's an 8. There's a positive sign here, there's a positive 10.
Mm-hmm.
So that's it. So the only things you care about are the constants. 16, 25, and -4. So that's 41 minus 4, which is 37, but I would check that maybe. I don't know. 16 for calculator section. 16 plus 25 minus 4 is 37. And it is a positive 37. So it looks like the answer is 37.
Yeah.
So you don't have to plug 4 and -5 into the equation. Right. If you wanted to plug 4 and -5 into the equation, then that has to make the equation happy. So that'll give you c. So you could do that, I guess. You could try it. 16 minus 8 times 4 plus 25, negative sign, be careful, -50 plus c is 0. Now that's more of calculating. You actually have to, that's more time, isn't it? 16, I did plus 32. It's 16 minus 32 plus 25 minus 50 is -41 plus c is 0. C is 41. Wow, we got the same answer using 2. Wait, hold on. Whoa. Wait a second. We got a problem here. This is the center. Of it. So right. Yeah. This is the center. So if you want to put that. Oh, wow. Yeah, that's the center of it, not a point on the circle. Right. So this is the way to go, right?
Well, what's the principle of what you get when you plug in the center coordinates? What is it that you plug the center coordinates into for getting something that's interesting?
That's a good point. You should get, when you have a circle
Yeah.
Let's use a simple case. X squared plus y squared is 25. You plug 0, 0 in because that's the center. You get 0 is equal to 25.
Mm.
You get, you
Well,
just
yes.
get, you get 0. You get 0 on this side of the equation.
Mm.
Right?
No. In general,
Yeah, if you have if you have the equation of the circle, x minus h squared plus y minus k squared, and you plug out of the center into the circle, you're going to get a 0 over here. Yep, aren't you?
well, the form of the uh let's see, what do we have here? Uh here is an example of here's the example. You take this example of the equation of a circle, which is in the form that reveals the center and the radius.
Right. Yeah.
Right, now let's transform this into a f of x equals 0 type equation. So we write f of x equals x minus 4 squared plus y plus 5 squared, and make it into equation form minus 4.
Okay.
This is f of x. Now, if you plug in the coordinates of the center, it's actually f of x and y. Right? It's f of x and y. And the equation of the circle is f of x and y equals 0. But what if you plug in the center? The center is not on this. It's not
Right.
on the the curve of the circle. So
That's
you
right.
certainly won't get f of center equals 0. Some other number. But what number do you get? Well, this is when if we look, so we could tell this by writing the f function in this form, that the center and radius form. You plug in the coordinates of the center, and we get f of, let's see, the center is 4, coordinates 4, negative 5, and what do you get? 0 squared plus 0 squared minus 4. So what you could see from this, in general, the 4 generalizes, the negative 4 generalizes to the negative radius squared.
Mm.
So this generalizes to negative r squared. So you say so here is an expression where call that f of x and y, where the equation for the circle is f of x and y equals 0, and f is monic.
Mm.
The coefficients of x squared and y squared are both 1. Well, if you plug in the center, what you get is minus 4.
Okay.
Right?
Yeah.
So you have to pick C, so that when you plug in the center into here, You pick C so that when you plug in the center over here, you don't get 0, you get -4.
Oh, so in other words, negative 41 plus C is equal to negative 4. Negative 41 plus C is equal to negative 4. Right?
Well, so you calculated this. You calculated this, and what you got was negative 41 plus C. That should equal minus 4 squared.
No, minus 2 squared.
Minus 2 squared. Yeah, minus 2 squared, which is -4.
Yeah.
Which gives you C, which is 37. Yeah.
Yeah. So
that works.
Second way of doing this is pretty
That's
dangerous.
yeah. So it's a right. It's a clumsy way to do it.
It's a clumsy way to do it. Yeah.
Especially since they did most of the work for you.
That's right. They gave you the equation of the circle, which is
no. They gave you the equation in the form where by completing the squares you can get it into center and radius form.
No, you don't have to complete the square of anything. They gave you the center and they gave you the radius. You could just write down the equation right there. You don't have to complete
yeah. So they gave you the center so that you could complete the square very easily because they told you what to do.
Oh, when you say complete square, you just multiply it out. You just multiply x minus 4 squared.
Yeah.
You just multiply out. Yeah, you just multiply this out.
Yeah.
Yeah. So they gave you all the work. You multiply that out.
Yeah.
You multiply that out. You compare all the terms. You compare the green box. You compare the green box is really important. You compare the green box to the what we have here is the red box. And then you just see what and you just pick off C. Yeah, that's the way to go for sure. Oh yeah.
Well, I think what's unusual about this question is that they give you extra information. Suppose they didn't tell you that the center was 4, -5.
Okay.
And all they did was give you the equation as they gave you with the C, and they told you the radius was 2. Find C.
Yeah.
You could do that.
Right. Right. That's right. And so they may have debated that while they were making the test.
Yeah. And also they took the risk of giving you an inconsistent question. They might if they made a mistake in telling you the center, then the question would be inconsistent.
Yeah.
Yeah,
because that's right. Because if you do that thing called completing the square here on this equation they give you, x squared minus 8x plus y squared plus 10y, you would see immediately that the center is at x is 4 and y is -5. Okay. Yeah. So let's see. Today's Throwback Thursday. First, why don't we answer our questions? Then maybe we should show how to complete the square. Just for people who want to remember how to complete the square. And then we can do Throwback Thursday. Okay. So, calculator section. Would a calculator help you here? Yeah, maybe. I mean, maybe. If you want to add these up with the calculator, sure. You can't back solve this because they didn't give you any answers. It's not a multiple choice question. How would this question differ from school? It doesn't feel at all like a school question, but it could be. I guess it could be asked in school. They may want you to complete the square, which we'll do in a second. Is there a pattern to this question that you could take advantage of, so that you can get the question done faster? Because the specific question has a pattern specific to this question. Not really.
Oh, the pattern is the given center and enough of the terms to tell you what the center is.
Yeah, but I mean, that's
unusual.
nothing
Yeah.
specific. Okay, and now what do you think the main idea of the test committee was to in this question, other than to test your general knowledge of how
Mm.
your general education level? Um, what do you think their idea? What do you think they were really aiming for here? Um, Certainly understanding the equation of a circle, and it really helps if you remember the equation of a circle, which is this blue the equation that's in blue, which is for people for just as a very important reminder as to what it is. It is equation of a circle is x minus, called it h squared, plus y minus k squared is r, and the coordinate of the center of the circle is h comma k, and r squared, r is the radius. So be very wise to know this going into the SAT, because if you know that, then you really can do the problem quite efficiently. So it looks like they really wanted you to know that. It's the key to the problem. So
No.
what? Okay, so should we quickly show how to complete the square for people who have heard of that but may have forgotten how to do it?
Yeah.
So, okay. So if you want to take this question, this equation, when do you complete the square? Under what circumstances do you complete the square? You complete the square when they give you equations that look like this, and you want to turn them into the equation that we just wrote. So to complete
I
the
would
square,
say to complete the square.
yeah,
Complete the square is when you have an expression of the form x squared plus a times x, and you want to find an unknown question mark such that when you add the question mark, you get x, shall we say, plus another question mark, double question mark, squared.
that's a little confusing.
So x plus ax, all by itself, is not the square of any polynomial unless a equals 0.
Yeah.
But for non-zero a, it's possible to add a constant such that you get a new polynomial that is the square of some other polynomial.
Yeah.
So this is what completing the square means.
Yeah. Right. That's why.
And it turns out that you could find a constant. So that and what is it? The way you find it is figure out what it must be. Well, if the right hand side is the square, then the right hand side has the form x squared plus 2 times this double question mark thing plus the double question mark squared.
Yeah.
Right.
Right.
So by matching terms, this would be an x there. So it's x squared plus 2 times double question mark times x plus double question mark squared. Matching terms tells you that 2 times double question mark has to equal A, and therefore a double question mark has to equal A over 2.
Yep.
And then you could figure out what the single question mark needs to be. The single question mark is the square of A over 2.
Yeah, which is A squared over 4.
Yeah, which is A squared over 4. Okay.
Right.
And then the variation is you're sometimes given another constant here. You say, and then you, what constant can you add to it? And so that you get the question mark that makes it square. All right. So do you want to explain it yourself, your way?
Well, that's all the theory. So I'm just gonna do it. I'm just gonna do it. I'm just gonna do it, schmoo it. Right. Okay. So that's all the theory. So you can see how I'm starting to go to sleep. So I'll just show you like train more in mechanical engineering. Just let's get it done. Okay. I'm not sure what happened there. Okay, 2, complete the square. You do x minus half of 8 to be 4. And you square that. Now, the problem here is that if you're comparing it to the top equation here, this adds a 16. So you better subtract a 16 here, because this really is x squared minus 8x plus 16. So you got to subtract a 16 in order to balance everything. Now we do the same thing with the y's. It's y plus 10. So instead of y plus 10, you do y plus 5, so that when you multiply it out, you get y plus 5 times y plus 5, which is y plus 10y. But this adds a 25 in there, so you got to subtract a 25 out of that. Okay, so far we've taken this equation and we really have written it the same way. Now you have a plus c. Okay. Now, for the equation of a circle, this has to equal r squared. So that has to equal 4. Because the equation of a circle is x minus the x value of the center squared plus y plus parentheses y minus the y value of the center squared equals the radius squared. So that will give us C, hopefully. Is that 37? No, that's not 37, is it? That's not 37. This is minus 41. Oh, yeah, it does. Yeah. C. No, but C. That's negative 4. What's wrong? Wait, the equation of a circle. Oh, they told us. No. They told us it was 0. Wait, now I'm really getting confused. They said the equation of a circle is that. If the equation of the circle is that, the equation of the circle is that. What's going on? We completed the square. We completed the square. That's negative 41 plus C minus 41. But they told us the equation of the circle is that. What happened?
Well, in the SAT question, they did not give the equation in the center radius form.
Right.
We are talking about converting an arbitrary equation into one with center radius form.
Right. Yeah. Wait, so it should be equals 4. It should be C. It should be this. Wait.
There's no reason.
No,
There's
there's
no,
no
you
C.
cannot
There's no
say that.
C.
That's
There's no
C.
C.
No,
There's no
C,
C.
C, C. You cannot. It doesn't make sense
Yeah,
to
they even have a C.
conclude that C is -4.
Right, right. No, no, no. I see the mistake. I see the mistake. I see the mistake. I see the mistake. There's no need to have the C in here. We're just trying to convert this into into the circle form. So it's this equals this.
Mm.
This thing. Sorry, this thing has to equal r squared.
Yeah.
This has to equal r squared. That's it. That's it, right? So we know r squared is 4. So this has to equal 4. Because that's what they said. They said that the equation, you complete the square.
What's it? -16 and -25. What's going on here?
Why, I'm completing the square for this thing. This is such a bad way of doing it.
You don't have a C in here.
Okay, I'll put the C back.
The C is in.
This is not the way.
Yeah,
this is obviously.
It's okay. So this is a question where you have to keep your wits about you.
Yeah,
Because they made it. They gave you. They made it an excess. It made a bit of a complication.
Yeah.
Because it's not quite. It's not. It's not. It uses. It uses a calculation similar. Except that let's see. Yeah.
Yeah, what a mess. What a mess.
Well, what they did was make a variation on the standard problem. The school standard problem is given the equation of a circle in expanded polynomial form.
Yeah.
Okay? Which means there's one constant and two other terms, x squared and a constant times x. And two more terms, y squared, a constant times y. X squared plus a constant times x squared, x. Y squared, another constant times y, plus a constant, right? And the school problem, typical school problem, is knowing that an equation of that form is the equation of a circle, to find the center and the radius of the circle.
Right. That's a normal question. That's a question.
Yeah, and then a directly related question is to find another equation that reveals the center and the radius explicitly.
Yeah, right.
And then the technique to solve that problem is to complete two squares.
Yeah.
Complete the square that begins with x squared, and then complete the square that begins with the y squared, and therefore then but you need to preserve the equation. Complete the square by making it neat. What you do with completing the square is to generate an equation that has, x within a square, y within the square, a constant sitting outside everything, where the equation you get is equivalent to the equation they give you.
Right.
And when you do that algebraic process, you can read off what the center and the radius are.
Yeah.
So what they did here was solve that problem partially and then they ask you to read off what one of the coefficients is.
Yeah. Yeah. So
And then they put the coefficient to read off. They stuck it in the middle of the left hand side of the equation instead of putting it on the right.
So the thing is, the only reason to complete the square really is to get the center of the circle. This is why you complete the square, to get this information. Since they gave us this information, it's not a good idea to complete the square. Because once you have this information, you could write the equation of the circle like we did, and then you can get the answer.
Yeah.
So stay away. I always say, stay away from completing the square unless you absolutely have to. And in this case, if you complete the square, you just run into a really confusing brick wall. So this question's tough enough, so I think we should check the answer. Now, I'm going to have to... Oops. What do I have to do? Okay. Right now, okay. So let's clear the screen. And I will quickly check the answer. So that's just everybody, please wait. So what are we going to do with Throwback Thursday? This was 37. I'm right there already. 37. Calculator section. Oh, no, it was question 38. It was question 38. Yeah, the answer is 37. So let's just get a sense as to how difficult they thought this question was. Okay. Just bear with me one moment. Let's just get a sense of difficulty. They called this a third level difficulty question. Yes, level 3. And the section they called it was not applicable, which doesn't make any sense. As opposed to heart of algebra, problem solving, advanced algebra, advanced math, they called it not applicable, which, I wonder if not applicable means it was a test question. Who knows? Anyway, they called it difficulty level 3. Okay.
That means maximum?
Yeah, that means maximum, yeah.
Oh.
Yeah. Okay. So I guess we're done with that. We really got to know the equation of a circle. So today's Throwback Thursday. So we go back we go back to about 20 years ago, 25 years ago, this really old-looking book with they have practice questions from the SAT. And you'll see the questions there had a whole different feel, or some of them at least did. This was a question they asked a lot. It was on almost every test. You have to choose if column A is greater than column B, or column B is greater than column A, or they're equal, or you can't tell. So let's go for it. Here we go. I hope everyone can see it. The column A, okay, the first number in a sequence of 10 numbers is 3. Okay, I'm just getting my annotation ready. The first number in a sequence of 10 numbers is 3. So they're just saying 3, 4, 5, ...
No. How do you know? Maybe it's 3, -6,
No.
14, 98, 57.
That's just an example. You're right. 3, 99. Even, it can even be negative 99. Right? It could be plus 105. It could be anything. The sum of the 10... They don't say anything whether it's arithmetic or geometric.
Nope.
The sum of the 10 numbers in the sequence, or 30. Weird question, right? You never
Yes, it's really weird.
You would never see anything like this on the post-2016 SAT. Because the post-2016 SAT just tested what you learned.
They want to catch people like you who wrote down 3, 4, 5, etc.
But you interrupted me. You interrupted me. You didn't wait for me to write another sequence. You just thought I was this. You
wrote 3, 4, 5, ...
Yeah, up to whatever 10 of them.
Yeah.
But then you didn't give me a chance to write another one. I was going to write 3, 4, 5, ... up to 10. Or not, whatever. And then I was going to write 3, 8, 9, 12, some random stuff. 10 of them. You didn't give me a chance. the sum. Wait a second. So does this mean it seems like you can't really tell, right? D.
Right, right.
Yeah, you can't really tell.
Yeah.
But this is such a weird question that we are going to have to go to the answer book. So that's section 3, number 11. So let's see what the answer is. Section 3, number 11. Just bear with me. Boy, back then they had like 7 sections. Oh, so weird. So different from the new test. Section 3, number 11 is D. And they called it level difficulty 4. 4 out of 5. So that's the way they did it.
Yeah.
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 Okay. And how much time
Yeah.
did they give you? They gave you 15 questions in 25 questions in 30 minutes. Yeah, that's about the same.
Yeah.
Okay, so that's the Throwback Thursday question of the day. A week. Okay, everyone. So I'm Joel. I have a PhD in mechanical engineering. I just want to get the problem solved, but I crash sometimes. And there's my brother Seth, who has a PhD in math to help us and help me get out of the woods after the crash. So we have different approaches to doing the problems, and we offer what we try to do every day is we go through an SAT question, we discuss it, we knock it around, we look at it different ways, we try to gain as much insight into the problem as possible. And that's what you should do when you do these problems after you do them, particularly the ones you get wrong. Really think about them from different assets and different facets, different lenses. So, and then to study for the math SAT, do as many practice questions as you can. On the digital side, particularly, download the Blue Book app and do those 4 Blue Book tests. And any topics you're not sure about or you're weak on, go to Khan Academy. They have a digital SAT course that's sanctioned by the SAT. That gives you about 20, 30 questions per topic. It's great. You can study the topics there. And just practice, and learn from your mistakes and try to figure out what you don't know, and try to work on those particular topics. So that's about it, right? If you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com, and we'd be more than happy to do them together right here. Okay, everyone. I guess have a great day. Bye-bye.
Bye-bye.